Okay, so let me run this code. It's a code for simulation of a pendulum with damping. So for damping, it's gradually slowing down. So how I have done this? So first of all, I have import these things. We will use it later. And then I have set some parameters. So first of all, I have to make a differential equation. So how to make that differential equation? Let's say this is a pendulum and the object's mass is m and the length is L, and this is mg, so we can divide this into component. So this is mg sine theta if this angle is equal to theta, and this is mg cos theta. Okay, so we don't need actually mg cos theta, we will need mg sine theta. So first of all, we have to define alpha. So we know alpha, the angular acceleration, is torque divided by moment of inertia. So here moment of inertia is m into L square, simple, if I assume that it's a simple pendulum, and the torque is mg sine theta, then L. But here one thing, that we are assuming the positive at z-axis, that means alpha is pointing at z-axis, that means mg sine theta is opposing. If the alpha is above the positive z-axis, so mg sine theta is opposing this motion, so we have to write here 1 minus. Okay, so another is for damping. So it's a damping coefficient, that's a k, and damping always acts on opposite to the velocity, that is omega. So alpha can be written as d omega by dt. Now what is theta? Sorry, what is actually omega? Omega is simply d theta by dt. Okay, so we have to find theta. So we have some equations, d omega by dt, then d theta by dt is omega. Now we have to find theta. So how we can do this? So first of all, I have to make a solution variable, and this is solve IEBP. This is the function which is inside scipy dot integrate, and it takes pendulum ODE. This is a function, and I have created this function here, pendulum ODE. Then t-span is the time period for, let's say I want to simulate the animation from 0 to 10 seconds. And then initial states. Okay, so what is initial state? So let me talk about initial state. Initial state is initial theta, initial omega. So let's assume that initial theta is pi by 6. So initial state is pi by 6, and here the angular velocity is 0, so this is 0. That's why initial state is pi by 6 to 0. Okay, well, so solution, and solution inside solution variable I have pendulum ODE, t-span, initial state, then t evaluation, that means at which time we want to find the solution. I will find theta, right? I will find theta, so I have to choose in which time I want to find the theta, value of theta. So t, I have defined t. So t is, this line gives me about information of t. So what is t? T is from 0 to 10 seconds, and I have here 500 time. I have here 500 indexes. You see, from I have here 500 indexes. Okay, now method is Rangagupta method 45. And now how this thing works. So first it will call this pendulum ODE. So let's see what is inside this pendulum ODE. So first of all, I have defined y, and y is equal to theta and omega. So you see y is theta and omega. Okay, so y is theta and omega. Now we know that d theta by dt is simply omega, right? So I have write this thing here, and then I have write the equation of alpha, which is actually d omega by dt. So d omega by dt, I have write the equation here, and then I have returned this d omega by dt. That means I have then returned d omega by dt, sorry, first d theta by dt and then d omega by dt. So I have returned these two things, and after taking these two things, the solution variable will find the solution and find the solution in this time. Okay, so let me see that what is theta. So let me run this portion, and let's see what is theta. So you see theta, I have 500 theta here. As I have 500 times, as I have here 500 times, so I have 500 thetas here. This is 500 positions, and now I want to convert that into xy coordinate. So as this is theta, so let's say this is the origin. So this is the origin, so this might be x and this will be y. So what is x, and this is L. So we can write this is y, so y is equal to L sine theta. But as y is to the downwards, so we have to write here minus, and then x is equal to, y is equal to L cos theta, and x is equal to L sine theta. And you see that x is at the rightward, so we have to put here plus. So I have convert those theta into xy coordinate. So I have the position of this object in xy coordinate, and now I have to plot this thing. Okay, so to make an animation, I have used this func animation, which I have defined here. You see matplot.animation input func animation, function animation actually. Okay, so this first I have defined some variables, figure and axis, and then I have set the x and y limit. This is for let me run this simulation again. Okay, so this point axis dot plot, I have defined this origin point here, and then I have defined a line here, and then I have defined two functions, init and update. These are my functions because this is used in animation function inside. If you put your cursor in func animation, you will see what is the requirement of this function. So first it takes the figure, then update. So this is my update function. For this figure, this is figure, plot the subplots, it returns figure and axis variable. So this is figure, and then there is update. So what is update? During the simulation we have to update the positions, right, because the object is moving. So I have this is actually time. F is some instant time, let's say 0.1 second or let's say 0.1 second. So at 0.1 second you are making current x and current y, and then you have set the line's position. Okay, so 0 is the x of origin. I mean, let's say this is a line. This point's x is 0 and this point's x is f. And what is f? F is, let's say, some instant time. Let's say at 0.2 second. At 0.2 second, I want to update the line. And the origin's y is 0 and the origin's y is f. So that's why I have set the line with line.setData, and then I have returned line. Okay, so now init function, which is init, I have defined this init here. Just a formality, you can say, as this is the requirement for the function. This function requires an init function, so I have function here. Then what is interval? I know that inside time I have 0, then 0.1, 0.2 up to 10 second, right? And I have here 500 numbers. So what is interval? Interval is the difference between these two numbers. This is t0 and this is t1. So interval will be t1 minus t0 second, right? But hold on, this interval is taking the value in milliseconds. So what I will do, I will multiply 1000 to make it millisecond, because it is the requirement of the function animation. And do I want to repeat? Yes, I want to repeat. That means from 0 to, it will simulate from 0 to 10 second, and then again it will simulate from 0 to 10 second, again it will simulate for 0 to 10 second. I mean, after 10 second it will not pause, and then plot.show. Okay, so if I run this simulation again, I have run it. Sorry. So if I run this simulation, where is that? Okay, so this whole code is from Gemini, and I have updated something after taking that code from Gemini. So this is thus you can make any simulation whatever you want.